So before the break, we came up with a plan. We needed to find sine of 2x. We wanted to use a double angle identity, which means we need sine of x, which means we need cosine of x. And this is the only double angle identity for sine of 2x that we could think of at the time. So we needed a way to get sine and cosine from the tangent. Tangent is negative 3/7. So if we put that together with the Pythagorean identity, tangent will get us to secant. And from secant, we can get to cosine. So we did that over here. Tangent squared is secant squared minus 1. Tangent is negative 3/7. And then we did some algebra to find the secant squared. The trig part comes in when we get the plus or minus. If I have the secant squared is 58 over 49, I need to take the square root of both sides to put a plus or minus in front of things. But we know that x is in quadrant 2. Maybe this is where we need that information. Because x is in quadrant 2, the secant and cosine are both going to be negative. So the secant is negative root 58 over 7. So cosine is negative 7 over root 58. No problem. Now we can use the reciprocal identity to take our tangent of x and write it as cotangent of x. I could say cotangent of x is negative 7/3. Then I can use the Pythagorean identity, cotangent squared is cosecant squared minus 1, and do the same thing to find out the sine of x is 3 over root 58. In this case, I want the positive square root because x is in quadrant 2 and sine is positive in quadrant 2. Once I have those two bits, I can plug them into my identity or my double angle identity for sine and get 2 times 3 over root 58 times negative 7 over root 58 for a total of negative 42 over 58 or 21 over 29. No problem. That was a great plan because it worked. This is, of course, not the only thing that we could have done. The reason I like opening up with this plan is because this plan involves the most calculation. That makes it the most fun. There is another double angle identity for sine of 2x that I didn't tell you about because this came up. And so I said, well, we have a plan and all we need is a plan. But now we need to know more plans. So there's another double angle identity for sine. We not only have sine of 2x is 2 sine x cosine x. We can also write sine of 2x as 2 tangent x over 1 minus tangent squared x. Oh, sorry, 1 plus. And you're thinking, well, shit, wouldn't that be easier? Since we have the tangent of x? Well, yeah, totally, but that's not the one that came up first. So if we had remembered this trig identity, we could have just taken the tangent of x and plugged it into this one. So we could have written 2 times a negative 3/7 over 1 plus the negative 3/7 squared. So I got negative 6/7 divided by 1, spelled 1 wrong. 1 plus 9/49. So we'll get negative 6 over 7 times, oops, down here we'll have 49 plus 9 is 58. So times 49 over 58, because I'll multiply by the reciprocal. Then we can simplify. I can take a 7 out of the 49 and take a 2 out of the 58. What's half of 58? 29. So I get this negative 21 over 29. So there is a double angle identity for sine that's written in terms of tangent. This doesn't come up as much when we search, that, which is why when that first website that I opened, I was kind of surprised that they had it. So that I thought that was pretty cool. So I immediately scrolled past it so that we can see the cosine with the tangent. There's a cosine tangent one. Because I knew sine of 2x was going to be coming up, and I wanted to see if anybody remembered the double angle identity sine that's written in terms of tangent. The place that comes from, if we write 2 times sine x cosine x, I can take that sine, and I know that sine over cosine, sine divided by cosine, is equal to tangent. So what we can do is start messing with this expression to try to produce some tangents. So what we could do here, I want if I had a cosine in the denominator, then I could pair this denominator cosine with the sine up here and make a tangent. But I can't just take an expression and divide by cosine. I can multiply by 1. And that won't change anything. So I'm going to multiply by cosine over cosine. Then what we're going to do is this cosine is going to be the denominator of the sine. So I'm going to write 2 sine x. And I'm going to divide this sine x by the one of these cosine of x. Then the other cosine of x gets multiplied by the original cosine x and gives me cosine squared x. So there are the cosine in the numerator and the denominator that I added. Now that sine x over cosine x, that is going to be written as tangent. Because sine x over cosine x is equal to tangent. But you're like, oh, dude, that does not look like what you have written down. That's 2 tangent x times cosine squared x. But that's okay, because cosine squared is 1 over secant. Not obviously helpful right now, but cosine is the reciprocal of secant. So that cosine squared can be written as a secant in the denominator. So I'm going to have 2 times the tangent of x divided by cosine squared in the numerator will be a secant squared in the denominator. And you're like, oh, dude, that still does not look like the tangent stuff. But that is a secant squared in the denominator, and secant is related to tangent. Secant squared is 1 plus tangent squared. And there we have another double angle identity for sine, this one in terms of tangent. Yeah. Because we already have a double angle identity for sine that involves 2 trig functions. Sine of 2x is 2 sine x cosine x. So that one involves 2 trig functions. Right. It's the same reason we have 3 different double angle identities for cosine. So we could list 2 tangent x cosine squared as a double angle identity for sine. It involves 2 trig functions, but we like to have it involve as few trig functions as possible. But notice we have 3 for the double angle identity for cosine. Cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. So we can do cosine of 2x in terms of cosine and sine, in terms of cosine only, and in terms of sine only. So if we can get a double angle identity for sine in terms of tangent only, that's pretty cool. We've already got one in terms of sine and cosine. So which one is better? Whichever one occurs to you to do first. If you happen to not remember this double angle identity for sine, then you kind of have to go through and get sine and cosine, which you totally can. This is, of course, not the only way we could have got at the sine and cosine. Notice that our sine and cosine had a -7 and a 3, and then they both had this square root of 58. Why do they both have a square root of 58? The sine involved 3, the cosine involved 7. So if we go back to the first week of class, ignore the negative because we know that this is in a second quadrant, and just build a right triangle where the tangent of x is 3/7. So that means opposite is 3 and adjacent is 7. We can use the Pythagorean theorem to come up with the hypotenuse. Oops, 3 squared. And so the sine of x is opposite over hypotenuse, and cosine x is adjacent over hypotenuse. Yep. In this case, we would have had to remember that we are in the second quadrant. So cosine is negative, but sine is positive. Yeah, just leave it as square root of 58. That way we don't have to round stuff off in our calculating. Also, if we just write down all the decimals, we would miss out on this common square root of 58 showing up all over the place. And it might not have occurred to us to just find sine and cosine using a right triangle. Oh, once we have sine and cosine, then we could use the double angle identity. 2 of this product. The best way to do the problem is whatever occurred to you to do first. If you went through all the extra effort using all the identities at the beginning with the Pythagorean identities and the square roots and all that stuff, and came up with -21 over 29, I'd be perfectly happy with that. If the person sitting next to you made a little triangle and came up with -21 over 29, I'd be perfectly happy with that. If someone happened to remember the double angle identity for sine in terms of tangent, I'd be like, oh, that's weird. Almost no one remembers that, but I'd be perfectly happy. Whatever gets you to the end of the problem, whatever occurs to you to do first, that's the best answer. If you're trying to learn things to move on into the future, the best thing to know is all the things. The best tool to have is all the tools. That makes sense? It's better to know more. Unless you're trying to be happy. Because ignorance is bliss. And if ignorance is bliss, then knowledge is the opposite of bliss. Sadness. Knowledge is sadness. Also, the more you know, the less money you make. I don't know if you know that. You can fold the wrong thing. Money and knowledge are inversely proportional. Knowledge goes up, money goes down. Knowledge and money are inversely proportional. What do we know? What have we been told? in America? What is time? Time is money. But you all are in school, and so you've been told another thing. Knowledge is what? Knowledge is power. Has everybody heard that one before? Knowledge is power. It's not true. Money is power. But anyway. That makes sense though, because knowledge is time. But anyway, if time is money and knowledge is power, work, this is from physics. You can look it up. Work is power times time. Work is a product of power. Oops, I wrote time first. Time multiplied by power. If you have a lot of time and little power, you can get some work done. If you have a lot of power and you can get the same work done in less time, right? Work is power multiplied by time. Work is the product of power and time, but time is money. And power is knowledge. So work is money times knowledge. Solve for money because you all want to make more money. So work is money. Money is work divided by knowledge. So as knowledge goes up, money goes down, regardless of the amount of work. The more you know. They don't finish that sentence because they don't want they want you to stay in school. They're like, oh, the more you know, the less money. QED. At this point, I'm supposed to tell you that hard work will produce results, but hard work has nothing to do. Hard work has fuck all to do. It's not about hard work. If you wanted to be financially secure and wealthy, or even wealthy, and you were not born into it, you've already made the biggest mistake. You should have been born to rich parents. You should have picked rich parents. And if in America, you should pick rich white parents. If you didn't do that, I mean, come on, man, you already messed up. I mean, you just look at the zip code, right? Before you're born, look at the zip code. Like, no, I don't want that one. I want this zip code where all the rich kids are. Pick that one. All right. Any questions? I'm just kidding. You didn't mess up. We messed up. Yeah, we're very lucky for that.
I don't know if one thing said it's
Looking around, looking anywhere from America, depending on where you are in America, it's like, oh, I don't know.
Oh, yes. We let immigrants come there? No. What about Sweden? No. Finland? No. Iceland? No.
Yeah, well, we're assholes. Anyway, what are we talking about? Oh, yes. So every time I teach you a thing, you learn it, you get less money overall, regardless of the amount of work you put in. So I don't know what y'all are doing. I'm going to school to make money. That's not how it works. But I'm going to work real hard. Clearly, it's not even a factor. The more you know, the more work you have to do to keep the money constant. Work and knowledge, or sorry, money and knowledge are inversely proportional. Yeah, see, they're also inversely proportional. All right. That's going to do it for today. That was some more identities. Knowing more identities. See, this is not true, because if you know more identities, you can do less work. But acquiring more knowledge costs more money. So this is all just kind of a mess. Except for the facts, you should know that there's nothing that I do in this class that you can't learn on the internet for free. So what you need to do is, what you need to realize is that you're not actually here in school to learn a thing. You're here in school so that you can be certified in that thing. It's not, knowing the stuff is not important. My certification at the end of the project, that's what matters. And if you had more money, you would just buy that. That's how I know that you don't have enough money to bribe me, because if you did, you wouldn't be here. You'd be at like Harvard or Yale or something like that.
You think it's a bribe?
No, you don't have enough money.
Dude, this class got a lot easier.
It got a lot easier if you had more money, but then again, you wouldn't be bribing me. You'd be bribing like Harvard or Yale, Princeton.
Or it's still you.
The students that I get, they're not gonna have enough money to bribe me.
You don't need money. I'll have a third.